Section 8 of Perfumes and Their Preparation. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in January 2018. Perfumes and Their Preparation by George William Askinson. Chapter 7. The Extraction of Odors, Part 1. Excepting the articles made in Turkey and India, especially oil of rose, most aromatic substances are manufactured in southern France and the adjoining regions of Italy, while a few, oils of peppermint and lavender, are produced in England, a few also, oils of peppermint, spearmint, wintergreen, sassafras, etc., in the United States. However, as we have stated above, it is possible to cultivate some plants from which odors are extracted in the warm sections of this country, and to obtain the most expensive perfumes from them. Among these plants, our experience leads us to suggest violets, roses, reseda, lavender, mints, syringa, lilac, and several others to which the climate is adapted. The methods by which the odors can be extracted from the plants differ according to the physical properties of the raw material and the chemical composition of the aromatic substance. We shall here briefly describe the methods thus far known, and at the same time add our own experience in this most important part of the art of perfumery. The aromatic substances are obtained by pressure, by distillation, by maceration, infusion, by absorption, enfleurage, through air or through carbonic acid, and by extraction. Pressure. Certain aromatic substances that occur in large amounts in some parts of plants are best obtained by pressure. The rinds of certain fruits contain an essential oil in considerable quantities enclosed in receptacles easily distinguished under the microscope. When these vegetable substances are subjected to strong pressure, the oil receptacles burst and the essential oil escapes. The force is usually applied through a screw press with a stout iron spindle, the vegetable substances being enclosed in strong linen or horsehair cloths, placed between iron plates, and subjected to a gradually increasing pressure. Comparative experiments have shown us that even with the most powerful presses a considerable amount of oil is lost owing to the fact that a large number of oil receptacles remain intact. For this reason, when oil is to be extracted by pressure, a hydraulic press is preferable, as it develops greater power than any other press. In the hydraulic presses used for this purpose, the piston fits exactly into a hollow iron cylinder with sieve-like openings in its circumference. The vegetable substances are filled into this cylinder. When the pressure is applied, the fluids escape through the perforations, and the residue forms a compact woody cake which is then free from oil. Besides the essential oil, watery fluid is expressed, the whole appearing as a milky liquid, owing to the admixture of vegetable fibers, mucilage, etc. It is collected in a tall glass cylinder which is set in a place free from any vibration. After remaining at rest for several hours, the liquid separates into two layers, the lower being watery and mixed with mucilage, that floating on top being almost pure oil. The latter is separated, and finally purified by filtration through a double paper cone in a funnel covered with a glass plate. It is best to separate the water and oil in a regular separatory funnel, or in a simple apparatus illustrated in Figure 4. It is made by cutting the bottom from a tall flask and fitting into the neck by means of a cork a glass tube having a diameter of 1/4 to 1/2 inch. A rubber tube with stopcock is fastened to the glass tube. By careful opening of the stopcock, the watery fluid can be drained off to the last drop. To the perfumer this method is of little importance, since it is applicable only to a few substances which, moreover, give cheap odors. Still, the possession of a hydraulic press is advisable to every manufacturer who works on a large scale, as it is useful also in the preparation of several fixed oils frequently employed in perfumery, for instance, oils of almonds, nuts, etc. Fixed oils are best extracted in so-called drop presses, the material having first been comminuted between rollers. These are arranged as shown in section in Figure 5 and in ground plan in Figure 6. The apparatus consists of two smooth or slightly grooved iron cylinders A and B, respectively 4 feet and 1 foot in diameter, which can be approximated or separated by means of set screws. The material is placed into the trough F, containing a feeding roller moved by the belt P. The scrapers FF, pressed against the cylinders by means of weighted levers, free the rollers from adhering pieces. The drop presses Figures 7 and 8 consist of a hydraulic press with cylinders A and piston B. The troughs E are movable by means of rings between two vertical columns, and every trough has a circular gutter D for the reception of the expressed oil. The iron pots G have double walls, the inner of which has a series of openings at its upper part. These pots are filled with the bruised material to be pressed, and after this has been covered with a plate of horsehair tissue, are set in the press. As the piston rises, the troughs E sink into the pots, the escaping oil collects in the gutters D and thence passes into a receptacle. After pressing, the piston is allowed to sink back, the pots G are drawn aside, Figure 8, to tabular surfaces, and other pots are substituted for the exhausted ones. These drop presses are suitable for the extraction of all fixed oils, and also volatile oils present in orange and lemon peel, etc. Distillation. Many odors or essential oils possess the remarkable property that their vapors pass so largely with that of boiling water that they can be extracted in this way, by distillation, from vegetable substances, though the essential oils have a boiling point far above that of water. Distillation can be employed for a large number of substances. For instance, the essential oils present in cumin, anise, lavender, fennel, mace, nutmeg, etc., are extracted exclusively in this manner. For the extraction of odors in this way, according to the quantities of material to be worked, different apparatuses are used, some of the most important of which will be here described. For manufacturers who run without steam and are obliged to use a naked flame, the adjoining apparatus, Figure 9, will be advantageous. It contains of a copper boiler A, the still, set in a brick furnace. The latter is so constructed that the incandescent gases strike not only the curved bottom of the still, but also its sides through the flues Z left in the brickwork. The still, whose upper part projects from the furnace, has an opening O on the left side, closed airtight with a screw, which serves for refilling with water during distillation when necessary. To the margin of the still is fitted steam-tight the helm H, made of copper or tinned iron, having a prolongation, the tube R. The latter is joined to the conical projection V, which terminates in the worm K. In some apparatuses this projection is omitted and the tube immediately joins the worm. The latter is made of tinned iron and, as the cut shows, is arranged in coils and supported by props T in the wooden or metal condenser F. The condenser bears above a short bent tube B, and below, immediately over the bottom, an elbow tube E, long enough to reach above the edge of the condenser as indicated in the cut. The vegetable substances to be distilled can be put immediately into the still and covered with water, but in this case it is advisable to use a stirrer which must be kept moving until the water boils, otherwise the material might burn at the bottom. But this accident can also be prevented by applying a perforated false bottom to the still above the flues, or by enclosing the material in a wire sieve basket C. In place of the basket C, the apparatus can also be provided with an additional vessel containing the material to be distilled. In the still A, figure 10, the water is brought to boiling. The steam rises through the second still B, in which the material is spread on a perforated bottom. The steam, laden with the vapors of the essential oil, passes through the tube R into the condenser. It is very advantageous, and in large establishments altogether indispensable, to use steam in the distillation of essential oils. Figure 11 represents the arrangement of such an apparatus. The still B, which in this case may be made of stout tinned iron, stands free and is provided with a wooden jacket M for the purpose of retaining the heat. Immediately above the curved bottom is a perforated plate on which the material rests. The tube D, which enters the bottom of the still, is connected with the boiler which furnishes steam at moderate tension. H is the faucet for the admission of steam. H dot is the faucet by which the water escapes from the still at the end of the operation. After the still is filled with the material, the faucet A is opened gradually, and a continuous stream of steam is allowed to pass through the still until the operation is finished. When working with an open fire, as soon as vapors appear at the lower end of the worm, figure 9, cold water is admitted through the tube NE. As the cold water abstracts heat from the vapors and condenses them, it becomes warm, rises to the surface, and escapes through B, so that the worm is continually surrounded with cold water. If for any reason the saving of cold water is an object, its flow may be so regulated that the vapors are just condensed, the warm distillate being allowed to cool in the air. When working with steam, the cold water must be admitted the moment the steam cock is opened, and the flow of cold water should be ample during the distillation, which in this case is much shorter. The large apparatuses here described are generally used, especially for the extraction from vegetable substances of odors present in considerable quantity, for instance, mace, nutmeg, cloves, cinnamon, etc., or from bulky material as the various flowers. For very expensive odors, smaller apparatuses are often employed, the construction of which resembles that of the ones described. For this purpose, small glass apparatuses are very suitable. They are illustrated in figure 12. The still, a retort A, consists of a spherical vessel with a bottle neck T, which is either closed with a cork or carries a thermometer or glass tube, and with a lateral tube, the neck of the retort, connected with the adapter R. The latter passes into the condenser C. At the lower end of R is the bent adapter V, under which is placed the receptacle for the distillate. The tube C is closed with corks, at its lower end is the ascending tube H, and at its upper end the descending tube G. During the distillation cold water flows in through H, which cools the tube R and escapes at G. The tube C, as will be readily understood, acts like the condenser in the larger apparatuses above described. In order to prevent the breaking of the retort, it is not heated over a flame, but is set in a tin vessel B filled with water. The comminuted vegetable material is inserted with water through the upturned neck of the retort of the latter. The vessel B is filled with water which is raised to the boiling point. During distillation we obtain at the lower end of the condenser pure water and essential oil. When larger quantities are to be distilled, it is advisable to use a Florentine flask as a receptacle for the separation of the oil and water, figure 13. It consists of a glass bottle, from the bottom of which ascends a tube curved above. The latter rises high enough to bring the curvature slightly below the neck of the flask. During the distillation, the flask becomes filled with water W, on which floats a layer of oil O. The excess of water escapes through A at D until the flask finally contains more oil and very little water. When producing essential oils on a large scale, instead of the frail Florentine flasks, it is advisable to use separators, the construction of which is illustrated in Figure 14. They consist of glass cylinders, conical above and below, supported on a suitable frame. The water accumulating under the oil is allowed to escape by opening the stopcock. When the first separator is filled with oil, the succeeding distillate passes through the horizontal tube into the next separator, etc. When the distillation is carried on in an ordinary still, we obtain, besides the essential oil, a considerable quantity of aromatic water, that is, a solution of the oil in water. An apparatus which obviates the losses caused thereby is that of Schimmel described below, which is well adapted to the manufacture on a large scale. The apparatus is patented. The nearly spherical still D, Figure 15, is surrounded by a jacket M. The inlet steam tube R is connected with a branch r, which enters the interior of the still as a spiral tube with numerous perforations, while R opens into the space M. When r is opened, distillation takes place by direct steam. When R is opened, by indirect steam. When both faucets are opened, the still is heated at the same time with direct and indirect steam. The vapors rising from the still D pass through the helm C and the tube A into the worm K. The fluid condensed in the latter drops into the tin Florentine flask F. The aromatic water flowing from the latter passes back into the still D through the welter funnel T and is distilled over again, so that the entire distillation can be effected with very little water, and it is continued until the water escaping from the Florentine flask is freed from oil and odorless. When working with superheated steam, it is necessary to set under the funnel tube T a vessel twice the size of the Florentine flask, which is provided with a stopcock above and below. The lower cock is closed, the vessel is allowed to fill with water from F, then the upper cock is closed, the contents being allowed to escape into D by opening, when the cocks are again reversed. The use of superheated steam is important, especially with material which gives up the contained oil with difficulty, such as woods. For freeing the essential oil completely from water, we use a so-called separating funnel, Figure 16. This consists of a glass funnel T resting on a suitable support G, which is closed above with a glass plate ground to fit, drawn out below into a fine point S, and provided with a glass stopcock H. The contents of the Florentine flask are poured into the funnel, which is covered with the glass plate, and allowed to stand at rest until the layer of oil O is clearly separated from the water W. By careful opening of the stopcock, the water is allowed to escape, and the oil is immediately filled into bottles which are closed airtight and preserved in a cool and dark place. Maceration, infusion. Some odors, like those of cassie, rose, reseda, syringa, jasmine, violets, and many other fragrant blossoms, cannot be obtained by distillation as completely or as sweet-scented as by the process of maceration, which is in general use among the large perfumers in southern France. This process is based on the property of fats to absorb odorous substances with avidity, and to yield them almost entirely to strong alcohol. According to the fat employed for the maceration of the flowers, a solid fat like lard or a liquid like olive oil, odorous products are obtained which are known either as pomades or as perfumed oils, huile antique. By repeatedly treating fresh flowers with the same fat, the manufacturer is able to perfume the pomade or oil at will, and in the factories these varying strengths are designated by numbers, the higher numbers indicating the stronger products. The process of maceration is very simple. The fat is put into porcelain or enameled iron pots which are heated, in a shallow vessel filled with water to 40 or at most 50 degrees Celsius, 104 to 122 degrees Fahrenheit. The flowers are enclosed in small bags of fine linen and hung into the fat, where they are allowed to remain for from 1/2 to 2 days. At the end of that time the bags are removed, drained, expressed, refilled with fresh flowers, and replaced in the fat. This procedure is repeated 12 to 16 times or oftener, thus producing pomades or oils of varying fragrance. As the odors are much superior when the flowers are only a short time in contact with the fat, it is better to use an apparatus for continuous operation, Fig. 17. It consists of a box K made of tin plate, which is divided into from 5 to 10 compartments by vertical septa and can be closed watertight by a lid to be screwed on. The septa have alternate upper and lower openings. The compartments contain each a basket of tinned wire filled with the flowers for maceration. Then the lid is closed and the box heated in a water bath to 40 or 50 degrees Celsius, 104 to 122 degrees Fahrenheit. The stopcock H in tube R is now opened. This admits melted fat or oil from a vessel above to the first compartment, in which it rises through the basket filled with flowers whose odor it abstracts. The additional fat coming from above drives it over through the opening O2 into compartment 2, where it comes into contact with fresh flowers, passes through O3 into the third compartment, and so on through 4 and 5, until it finally escapes through R1, well charged with odor. According to requirements, a larger number of compartments may be employed. When all the fat has passed through the apparatus, it is opened, the basket is removed from compartment 1, the basket from number 2 is placed in 1, that from 3 in 2, etc. Basket 1 is emptied, filled with fresh flowers, and placed in compartment 5, so that every basket gradually passes through all compartments to number 1. In this way the fat rapidly absorbs all the odor. The odorous substances are abstracted from the pomades or huile antique by treatment with strong alcohol, 90 to 95%, which dissolves the essential oils but not the fats. The huile antique with the alcohol are placed in large glass bottles and frequently shaken. In order to abstract the odors from pomades, the latter are allowed to congeal and are divided into small pieces, which are inserted into the bottles of alcohol. A better plan is to fill the pomades into a tin cylinder with a narrow opening in front, and to express the pomades, by a well-fitting piston, in the shape of a thin thread, which thus presents a large surface to the action of the alcohol, thus hastening the absorption of the odor. The alcoholic solution obtained after some weeks is then distilled off at a low temperature. We shall recur to this hereafter. No matter how long the fats are left in contact with alcohol, they do not yield up to it all the odor, but retain a small portion of it, and hence have a very fragrant smell. They are, therefore, brought into commerce as perfumed oils or pomades, bearing the name of the odorous substance they contain: orange flower, reseda pomade or oil, etc. They are highly prized and are sometimes used again for the extraction of the same odor. Some odors cannot bear even the slight raise of temperature necessary for the extraction by the method of maceration or infusion. For these delicate odors, one of the following methods may be employed. Absorption or enfleurage. In this method, the absorbing power of fat is likewise used for retaining the odors, but the flowers are treated with the fat at ordinary temperatures. This procedure, which is employed especially in southern France, is carried out as follows. The fat, lard, is spread to a thickness of about 1/4 inch on glass plates G, 1 yard long and 2 feet wide, which are inserted in wooden frames R and sprinkled with flowers F. Fig. 18. The frames are superimposed, the cut shows 2 of the frames, and left for from 1 to 3 days, when fresh flowers are substituted for the wilted ones, and so on until the pomade has attained the desired strength. This procedure is very cumbrous and tedious, and therefore had better be modified thus. In an airtight box K, figure 19, we place a larger number of glass plates G covered with lard drawn into fine threads by means of a syringe. This box is connected with a smaller one, K1, which is filled with fresh flowers and provided with openings below and above, O and O1. The letter, O1, communicates by a tube with box K, at whose upper end is a tube E terminating in an exhaust fan, so that the air must pass through the apparatus in the direction indicated by the arrows. A small fan V, driven by clockwork, will answer. The air drawn from K1 is laden with odors, and in passing over the fat as shown by the arrows, gives them up completely to the fat. The use of this apparatus has very important advantages. The absorption is effected rapidly, requires little power, and the flowers do not come at all into contact with the fat, which therefore can take up nothing but the odors present in the air. Instead of charging the fat with odors by either one of the methods here described, carbonic acid can also be employed with advantage, by means of the apparatus illustrated in figure 20. The large glass vessel G contains pieces of white marble M, upon which hydrochloric acid is poured at intervals through the funnel tube R. A current of carbonic acid is thus developed, which passes through a wash bottle W filled with water, then through the tin vessel B containing fresh flowers, and finally into a bottle A filled with strong alcohol and set in cold water, after which it escapes through the tube E. The carbonic acid absorbs the aromatic vapors from B and leaves them in the alcohol, which absorbs them. G, R, W are made of glass, B of tin. Extraction. This method is based on the fact that some volatile liquids such as ether, chloroform, petroleum ether, or bisulfide of carbon possess the property of rapidly extracting the aromatic substances from flowers. When they are evaporated at a gentle heat, they leave the pure odors behind. In our opinion, this process is the best of all for the perfumer, and it is to be regretted that it is not more generally used. As a rule, we employ either petroleum ether or bisulfide of carbon, because these products are cheaper than ether or chloroform. The apparatus we use for this purpose is illustrated in figure 21. It consists of a cylinder C made of tinned iron, which is provided above with a circular gutter R terminating in a stopcock H, and which can be closed by a lid D bearing a stopcock O. A tube B with a stopcock A enters the bottom of the cylinder. The latter is filled with the flowers. The volatile liquid, petroleum ether, bisulfide of carbon, etc., is poured over them. The lid is put on and the gutter R filled with water, thereby sealing the contents of the vessel hermetically. After the extraction, which requires about 30 to 40 minutes, stopcock O is opened first, then stopcock A, and the liquid is allowed to escape into the retort of the still, figure 12. If the extraction is to be repeated, the water is allowed to escape from the gutter through H, the lid is opened, and the solvent is again poured over the flowers. For operation on a larger scale, the glass retorts are too small and should be replaced by tin vessels, figure 22, having the form of a wide-mouthed bottle F. They are closed by a lid D, which is rendered airtight by being clamped upon the flange of the vessel R, with iron screws S, a pasteboard washer being interposed. A curved glass tube connects the apparatus with the condenser of figure 12. The solutions of the aromatic substances are evaporated in these apparatuses at the lowest possible temperature, the solvent being condensed and used over again. The heat required is for ether about 36 degrees Celsius, 97 degrees Fahrenheit, for chloroform about 65 degrees Celsius, 149 degrees Fahrenheit, for petroleum ether about 56 degrees Celsius, 133 degrees Fahrenheit, and for bisulfide of carbon about 45 degrees Celsius, 113 degrees Fahrenheit. If it is desired to obtain the aromatic substances pure from an alcoholic extract of the pomades made by one of the above described processes, which is rarely done since these solutions are generally used as such for perfumes, a heat of 75 to 80 degrees Celsius, 167 to 176 degrees Fahrenheit is required. Another extraction apparatus illustrated in Figure 23 is well adapted to operations on a large scale. Its main parts are the extractor E and the still B. The former is set in a vat W, continually supplied with cold water. The still B is surrounded with hot water in the boiler K. To start the apparatus, the cone C is removed, the vessel E is filled with the material to be extracted, and C is replaced. The faucets H2 and H4 are opened. The solvent is poured into the still through the latter, when these faucets are closed and those marked H and H1 are opened. The water in K is heated until the contents of B are in brisk ebullition. The vapor rises through RH, is condensed on entering E, and falls in small drops on the material. This fine rain of the solvent dissolves the aromatic substances and flows back into B, where it is again evaporated, and so on. At the end of the extraction, the faucets H and H1 are closed, and H2 is opened. The vapors of the solvent pass through it into a worm, where they are condensed. The essential oil remaining in B is drained off by opening H3. For still larger operations more perfect apparatuses are employed, such as those of Seifert and Vohl. Seifert's apparatus, Figure 24, consists of a battery of jacketed cylinders. Steam circulates in the space between the cylinders and the jackets. Each cylinder contains a plate covered with a wire net on which the flowers to be extracted are placed. All the cylinders having been filled and closed, the solvent is admitted from a container above, through S and A into C2. When this is filled, the liquid flows through A2, B3, Cn into C. The solution saturated with essential oil leaves the apparatus through Dn and P and enters a reservoir. The course of the liquid is aided by the suction of an air pump acting on P. When the reservoir contains an amount of fluid equal to that in Cn, Dn is closed, An is opened, and C connected with C1 through Bn and C1. That the contents of C2 are completely extracted is shown by the fact that the liquid appears colorless in the glass tube inserted in B2. A1 and C2 are closed, A2 and C3 are opened, thereby excluding C2 from the current of bisulfide of carbon, which then flows through C3, Cn, C1. In order to permit the free flow of the bisulfide of carbon through S, despite the exclusion of C2, the faucets A1, A2, A3, An must be two-way cocks. In one position they connect S with B, in the other they close B and leave the passage through S open. In order to collect the bisulfide of carbon present in the extracted residue in C2, faucet G2 is opened and the bisulfide of carbon allowed to escape through H. The faucet E2 in tube L, on being opened, admits compressed air to C2, thus hastening the outflow. If nothing escapes below, faucets F2 and Fx are opened, steam enters through tube D between jacket and cylinder, the bisulfide of carbon vapor passes through G2 and H into the worm. After the expulsion of the bisulfide of carbon, C3 is emptied, refilled, connected with C1, and bisulfide of carbon admitted from C3 in the manner above described. An extraction apparatus which has been much recommended of late is the so-called Excelsior apparatus, made by Wegelin and Hübner, Halle A.S., which can be worked with any desired solvent. The construction of the apparatus, figures 25 and 27, is as follows. The solvent is admitted to the reservoir R in the lower part of the condenser B through the tube indicated in the figure. The material to be extracted having been filled into the cylinder A through the manhole, the apparatus is closed. The cold water is admitted to the condenser by opening a faucet. The three-way cock shown in figure 25 is so placed as to open a communication of the overflow tube with A. The faucet at the lower end of the reservoir R is now opened sufficiently, and the solvent passes into A from above, and as it descends, takes up more and more oil, flows through the sieve plate, and escapes through the tube at the bottom of A through the three-way cock, the overflow tube, and the drain tube into the accumulator C. The opening of a faucet now admits steam to the heating coil where the solvent evaporates, leaving the oil or fat behind. It is condensed in B, again returns to R, whence it passes once more through the faucet into the extractor A. The vessel C and the tubes leading to A and C are surrounded with felt to prevent loss of heat. A sample taken from the small cock at the foot of A, it has a small plate in this interior of the tube, will show when the extraction in A may be looked upon as finished. The solvent is distilled off or recovered from the residue in A in the following manner. First, the faucet in R is closed. The three-way cock A is set to establish direct communication between A and C, thus cutting off the overflow tube. Hence, all the solvent in A flows into C for distillation, while the oil is left behind. Steam being admitted to the residue, the solvent rises as vapor through the upper tube from A to B and collects in a liquid state in R. To drive off the last traces of the solvent from the fat or oil obtained, steam is blown into C by opening the valve. Besides the solvent, watery vapor enters B and forms a layer of water in R under the solvent. By taking a sample from the test cock of the reservoir C, which has an internal small plate, the termination of the process is ascertained. The gauge tube at the reservoir shows the level of the solvent and water. The water is drawn off by opening the faucet at the lower end of the reservoir. A is emptied through the manhole and by draining the oil from C through the discharge cock. The tube R is closed by a light valve so as to prevent evaporation of the solvent. All the apparatuses work without pressure so that there is no danger from overstrain. The solution of the essential oils in bisulfide of carbon are distilled off in the steam still illustrated in figure 27. The steam enters at H. The water of condensation escapes at D. The liquid to be distilled enters at E from a container at a higher level. The boiling is kept uniform by the stirring arrangement Hg. After the bisulfide of carbon is distilled off, air is passed through the oil by the curved tube A, which has fine perforations, so as to evaporate the last traces of the solvent. In Vohl's apparatus, figure 28, arranged for petroleum ether, the extraction is effected with the boiling fluid. Hence, this apparatus is better adapted for the cheaper oils than for the finest oils from flowers. The apparatus consists of two extractors A, the accumulator B, and the condenser C. Petroleum ether is allowed to flow over the substances to be extracted by opening the faucets VH, closing OGWE, and opening O, the course being through UX to B. When B is 2/3 full, the flow of petroleum ether is cut off, Steam is admitted through Y, and the contents of B are brought to the boiling point. The vapors pass through G and are condensed in F until the contents of A reach the boiling point of the solvent, when the vapors pass through I into C, and after closing M', the liquid passes through ML into the inner cylinder of the extraction apparatus and returns through UXX. After the contents of A are extracted, M' is opened, M closed, and steam is admitted through D into the jacket of A. The vapors of the solvent force the liquid part of the contents through UX into B. Overfilling of B is prevented by allowing the vapors of the solvent to escape at the proper time into the condenser through P by opening Q. Then V is closed, Q opened, and the steam present in A drawn off by an exhaust applied to P. As soon as P begins to cool, all the petroleum ether is distilled off, the steam is cut off at D, and the extract evacuated through T. The contents of B are brought into a still through D and E. By employing greater pressure, the extraction can also be effected by what is called displacement. The material to be extracted is placed in a stout-walled vessel S, Fig. 29, which is connected by a narrow tube at least 10 yards long with the vessel F containing the solvent. Stopcock H is first opened, then stopcock H1, which is closed as soon as fluids begin to flow from it. After the liquid has remained in contact with the material for from 30 to 60 minutes, H1 is opened very slowly. The liquid is allowed to escape and is displaced with water, which is made to pass out of F in the same way as the solvent, until the latter is completely displaced from S. After the solvent has been distilled off, the less volatile essential oil remains in the still almost pure, containing only traces of wax, vegetable fat, or coloring matter, which are of no consequence for our purposes. The last remnants of the solvent cannot be expelled by distillation, but by forcing through the essential oil a current of pure air for 15 or 20 minutes. The essential oils then are of the purest, unexceptionable quality. In the case of delicate oils, it is better to use carbonic acid in place of air for expelling the last traces of the solvent, as the oxygen may impair the delicacy of the fragrance. For this purpose we use the apparatus illustrated in Fig. 30. In the large bottle A, carbonic acid is generated by pouring hydrochloric acid over fragments of white marble. The carbonic acid passes into the vessel B filled with water, which frees it from any adhering drops of hydrochloric acid, then into C filled with sulfuric acid, to which it yields its water, so that only pure carbonic acid escapes through the fine rose at the end of tube D, which is made of pure tin, and as it passes through the oil in E, it carries off the last traces of the volatile solvent. In its final passage through the water in F, it leaves behind any oil that may have been carried with it. As all the aromatic substances change in air by the gradual absorption of oxygen, and lose their odor, become resinified, these costly substances must be put into small bottles which they completely fill, and be preserved in a cool, dark place, as light and heat favor resinification. The bottles must be closed with well-fitting glass stoppers. Aromatic waters, or eau aromatisée, such as jasmine water, eau de jasmine, orange flower water, eau de fleur d'orange, eau triple de Neroli, aqua naphé triplex, etc., are made by distillation of these flowers with water, and show in a faint but very fine odor. When they contain, besides, dilute alcohol, they are called spirituous water or esprit. Those brought into commerce from southern France are of excellent quality. End of section 8. Section 9 of Perfumes and their Preparation. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Abai in December 2017. Perfumes and Their Preparation by George William Askinson. Chapter 7. The Attraction of Odors. Part 2. The Yield of Essential Oils. The quantities of essential oil obtainable from the vegetable substances vary with the amount present in each. The following table shows the average quantities of oil to be obtained from 100 parts of material. Material: ajowan seed. Name of plant: Teichotes ajowan. Mean yield per 100 parts: 3.0. Material: Elant root. Name of plant: Inula helenium. Mean yield per 100 parts: 0.6. Material: Allspice. Name of plant: Myrtus pimenta. Mean yield per 100 parts: 3.5. Almonds, bitter. Amygdala amara, 0.4 to 0.7. Angelica seed, Archangelica officinalis, 1.15. Angelica root, Thuringia, Archangelica officinalis, 0.75. Angelica root, Saxon, Archangelica officinalis, 1.0. Anise seed, Russian, Pimpinella anisum, 2.8. Anise seed, Thuringia, Pimpinella anisum, 2.4. Anise seed, Moravia, Pimpinella anisum, 2.6. Anise seed, Chile, Pimpinella anisum, 2.4. Anise seed, Spanish, Pimpinella anisum, 3.0. Anise seed, Levant, Pimpinella anisum, 1.3. Anise chaff, Pimpinella anisum, 0.666. Arnica flowers, Arnica montana, 0.04. Arnica root, Arnica montana, 1.1. Asafoetida, Ferula asafoetida, 3.25. Avens root, Geum urbanum, 0.04. Basilicum herb, fresh, Ocimum basilicum, 0.04. Bay leaves, Pimenta acris, 2.3 to 2.6. Beer's berry, Uva ursi, 1.01. Beech tar, Betula alba, 20.0. Bergamots, Ab 3.4. Betel leaves, Piper betel, 0.55. Bitter almond meal, Amygdala amara, 0.95. Buchu leaves, Barosma granulata, 2.6. Butterbur oil, Tussilago petacides, 0.056. Calamus root, Acorus calamus, 2.8. Chamomile, German, Matricaria chamomilla, 4.0 to 6.0. Chamomile, Roman, Anthemis nobilis, 3.0. Caraway seed. Cultivate German, Carum carvi, 4.0. Cultivate Dutch, Carum carvi, 5.5. Cultivate East Prussian, Carum carvi, 5.0. Cultivate Moravian, Carum carvi, 5.0. Wild German, Carum carvi, 6.0 to 7.0. Wild Norwegian, Carum carvi, 6.0 to 6.5. Wild Russian, Carum carvi, 3.0. Cardamoms, Ceylon. Eletaria cardamomum, 4.25. Cardamoms, Madras. Eletaria cardamomum, 4.3. Cardamoms, Malabar. Eletaria cardamomum, 1.75. Cardamoms, Siam. Eletaria cardamomum, 1.35. Carrot seed. Daucus carota, 1.65. Cascarilla bark. Croton eleuteria, 1.5. Cassia flowers. Cinnamomum cassia, 3.5. Cassia wood. Cinnamomum cassia, 0.285. Cedar wood. Juniperus virginianus, 0.7 to 1.0. Celery herb. Appium graveolens, 0.2. Celery seed. Appium graveolens, 0.3. Checan leaves. Myrtus checan, 1.0. Cinnamon, Ceylon. Cinnamomum ceylanicum, 0.9 to 1.25. Cinnamon, white. Canella alba, 1.0. Cloves, Amboina. Caryophyllus aromaticus, 19.0. Cloves, bourbon. Caryophyllus aromaticus, 18.0. Cloves, Zanzibar. Caryophyllus aromaticus, 17.5. Cloves, stems. Caryophyllus aromaticus, 6.0. Common wormwood herb. Artemisia abrotanum, 0.04. Common wormwood root. Artemisia abrotanum, 0.1. Copaiva balsam, para. Copaifera officinalis, 45.0. Copaiva balsam, East Indies. Dipterocarpus turbinatus, 65.0. Coriander seed. Thuringian. Coriandrum sativum, 0.8. Russian. Coriandrum sativum, 0.9. Dutch. Coriandrum sativatum, 0.6. East Indian. Coriandrum sativum, 0.15. Italian. Coriandrum sativum, 0.7. Mogador. Coriandrum sativum, 0.6. Crisp mint herb. Menta crispa, 1.0. Cubebs. Piper cubeba, 12.0 to 16.0. Culilaban park. Laurus culilaban, 3.4. Cumin seed, Mogador. Cuminum cuminum, 3.0. Cumin seed, Maltese. Cuminum cuminum, 3.9. Cumin seed, Syrian. Cuminum cuminum, 4.2. Cumin seed, East Indian. Cuminum cuminum, 2.25. Curcuma root. Curcuma longa, 5.2. Dill seed, German. Anethum graveolens, 3.8. Dill seed, Russian. Anethum graveolens, 4.0. Dill seed, East Indian. Anethum sova, 2.0. Elderflowers. Sambucus niger, 0.025. Elemi resin. Icaica abelow, 17.0. Eucalyptus leaves, dry. Eucalyptus globulus, 3.0. Fennel seed. Saxon. Phoenicum vulgare, 5.0 to 5.6. Galician. Phoeniculum vulgare, 6.0. East Indian. Phoeniculum panmorium, 2.2. Galanga root. Alpinia galanga, 0.75. Galbanum resin. Galbanum officinale, 6.5. Geranium. Pelargonium odoratissimum, 0.115. Ginger root. African, Zingiber officinale, 2.6. Bengal, Zingiber officinale, 2.0. Japan, Zingiber officinale, 1.8. Cochin China, Zingiber officinale, 1.9. Hazel root, Asarum europaeum, 1.1. Heracleum seed, Heracleum spondylium, 1.0. Hop flowers, Humulus lupulus, 0.7. Hop meal, lupulin, Humulus lupulus, 2.25. Hyssop herb, Hyssopa officinalis, 0.4. Iva herb, Iva moscata, 0.4. Juniper berries, German, Juniperus communis, 0.5 to 0.7. Italian, Juniperus communis, 1.1 to 1.2. Hungarian, Juniperus communis, 1.0 to 1.1. Laurel berries, Laurus nobilis, 1.0. Laurel leaves, Laurus nobilis, 2.4. Laurel Californian, Oreodaphne californica, 7.6. Lavender flowers, German, Lavendula vera, 2.9. Linaloe wood, Elafrium graveolens, 5.0. Lovage root, Levisticum officinale, 0.6. Mace, Myristica fragrans, 11.0 to 16.0. Majoram herb, fresh, Oreganum majorana, 0.35. Majoram herb, dry, Oreganum majorana, 0.9. Marsh rosemary oil, Ledum palustre, 0.35. Masoi bark, Masoia aromatica. Masterwood root, Imperatoria ostrutium, 0.8. Matico leaves, Piper angustifolium, 2.4. Matricaria herb, Matricaria parthenium, 0.03. Melissa herb, Melissa officinalis, 0.1. Michelia bark, Michelia nilagirica, 0.3. Milfoil herb, Achillea milfolium, 0.08. Musk seed, Hibiscus abelmoschus, 0.2. Mustard seed, Dutch, Sinapis nigra, 0.85. German, Sinapis nigra, 0.75. East Indian, Sinapis nigra, 0.59. Pugliese, Sinapis nigra, 0.75. Russian, Sinapis juncea, 0.5. Myrrh, Balsamodendron myrrha, 2.5 to 6.5. Myrtle, Myrtus communis, 0.275. Nigella seed, Nigella sativa, 0.3. Nutmegs, Myristica fragrans, 8.0 to 10.0. Olibanum raisin, Boswellia, various species, 6.3. Opoponax raisin, Pastinaca opoponax, 6.5. Orange peel, sweet. Citrus aurantium, 2.5. Orris root, Iris florentina, 0.2. Parsley herb, Apium petroselinum, 0.3. Parsley seed, Apium petroselinum, 3.0. Parsnip seed, Pastinaca sativa, 2.4. Patchouli herb, Pogostemon patchouli, 1.5 to 4.0. Peach kernels, Amygdalus persica, 0.8 to 1.0. Pellitory root, Valeriana celtica, 1.0. Pepper, black, Piper nigrum, 2.2. Peppermint, fresh, Mentha piperita, 0.3. Peppermint, dry. Mentha piperita, 1.0 to 1.25. Peru balsam, Toluifera perere, 0.4. Pimpernel root, Pimpinella saxifraga, 0.025. Poplar sprouts, Populus niger, 0.5. Rhodium wood, Convolvulus scoparius, 0.05. Rose flowers, fresh, Rosa centifolia, 0.05. Rosemary, Rosmarinus officinalis, 1.55. Rue herb, Ruta graveolens, 0.18. Sage herb, German, Salvia officinalis, 1.4. Sage herb, Italian, Salvia officinalis, 1.7. Sandalwood, East Indian, Santalum album, 4.5. Macassar, Santalum album, 2.5. West Indian, unknown, 2.7. Sassafras wood, Sassafras officinalis, 2.6. Sabine herb, Juniperus sabina, 3.75. Snake root, Canadian, Asarum canadense, 2.8 to 3.25. Snake root, Virginian, Aristolochia serpentaria, 2.0. Star anise, Chinese, Ilicium anisatum, 5.0. Star anise, Japanese, Ilicium religiosum, 1.0. Storax, Liquidambar orientalis, 1.0. Sumbul root, Ferula sumbul, 0.3. Tansy herb, Tanacetum vulgare, 0.15. Thyme, Thymus serpilium, 0.2. Thyme, dry, Thymus serpilium, 0.1. Valerian root, German, Valeriana officinalis, 0.95. Valerian root, Dutch, Valeriania officinalis, 1.0. Valerian root, Japan, Patrinia scabocefolia. Vetiver root, Andropogon muricatus, 0.2 to 0.35. Violet flowers, Viola odorata, 0.03. Water yarrow seed, Philandrium aquaticum, 1.0. Winter sweet marjoram, Origanum creticum, 3.5. Worm seed, Artemisia maritima, 2.0. Wormwood herb, Artemisia absinthium, 0.3 to 0.4. Zedoary root, Curcuma zedoaria, 1.3. Fresh flowers as a rule contain more aromatic material than wilted ones. The yield of dry herbs, leaves, etc., is usually greater than that of the fresh, because the latter contain much water which is lost in drying. When such vegetable materials cannot be worked fresh, which is best, they should be completely dried, spread on boards, at a moderate temperature in the shade, and preserved in dry, airy rooms, special care being had to guard against mold. End of section 9.
Section 13 of Perfumes and Their Preparation. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Michelle Fry, Baton Rouge, Louisiana. Perfumes and Their Preparation by George William Askinson. Chapter 8. The Special Characteristics of Aromatic Substances. In the preceding chapter on the chemical properties of the vegetable substances, many of their characteristics have been described. In this place we need only describe the physical properties of the essential oils, and with some of them to lay stress on those peculiarities by which they are specially differentiated. This knowledge is of the greatest importance to the manufacturer of perfumery, because no single individual is in a position to prepare all aromatic substances himself, but must rely on commerce for some of them. And in no group of chemicals is adulteration as frequent and as difficult of demonstration as among the aromatics. These adulterations are carried so far that many essential oils occurring in commerce under certain names often have nothing in common with the substance for which they are sold but the name. Oil of cassie. The oil of Acacia farnesiana is greenish yellow and viscid. The density and boiling point, which are of the greatest importance with reference to the genuineness of an essential oil, are not yet accurately known. Moreover, this oil never occurs in commerce as such, but its odor is present in perfumes, fixed oils, and pomades. Oil of anise should be colorless or faintly yellow. A dark yellow indicates old or inferior quality. The characteristics of this oil are the odor, its aromatic sweet taste, and especially the property of solidifying at a comparatively high temperature, 10 to 15 degrees centigrade, 50 to 59 degrees Fahrenheit, which is due to the separation of a stearoptin, anethol. Oil of anise is frequently adulterated with or replaced by oil of star anise. Oil of star anise. The easy solidification of the oil of anise is not always proof of its good quality, for the oil from anise chaff, which congeals at a still higher temperature, is sometimes mixed with it, and this has a less fine odor than that distilled from the seed. 1 part by weight of oil of anise is soluble in an equal weight of alcohol of 49%. Oil of bergamot has a pale yellow color, which becomes greenish when the oil is kept in copper vessels, and a strong, agreeable odor. This oil requires the greatest care in its preservation, as it abstracts oxygen from the air with extreme rapidity, and when it changes its superior odor so that it can hardly be distinguished from oil of turpentine. Oil of bitter almond, Oleum amygdal amare. When pure, is a colorless, refractive liquid which is heavier than water. The vessels in which this product is preserved must be stopped airtight, for in the air the oil very quickly changes into a white, odorless mass of crystals consisting of benzoic acid. Oil of bitter almond is formed by the action of the amygdalin upon the emulsin present in the fruit. Bitter almond meal being deprived of fat and left in contact with water for some hours at 40 to 45 degrees centigrade, 104 to 113 degrees Fahrenheit. Besides oil of bitter almond, sugar and prussic acid are likewise formed. The crude oil distilled from the meal is freed from the prussic acid by agitation with ferrous chloride and lime water and redistillation. Oil of cajeput, Oleum cajeputi, has usually a greenish color and has a burning, camphoraceous, and at the same time cooling taste. It has a peculiar odor resembling that of camphor and rosemary. Oil of calamus, Oleum calami. This oil, which is very viscid and of a yellow or reddish color, must usually be mixed with other essential oils in order to furnish pleasant perfumes. Oil of chamomile, Odium camomilia. Oil of chamomile, from Matricaria chamomilla, common chamomile, which is specially characterized by its magnificent dark blue color, has a marked narcotic odor and is very high priced, owing to the small yield of oil by the flowers. The oil from Anthemus nobilis, Roman chamomile, has also a blue color, which gradually becomes greenish yellow. Camphora. This essential oil differs from the others mainly by being firm and crystalline at ordinary temperatures. Chinese or Japanese camphor melts at 175 degrees centigrade, 347 degrees Fahrenheit, and boils at 205 degrees centigrade, 401 degrees Fahrenheit. Camphor is seldom used alone, as its odor is heartily fragrant, but it finds frequent application in the preparation of mouthwashes, toilet vinegars, etc. In commerce, so-called Borneo camphor is also met with, though rarely, which closely resembles the Chinese in appearance and other qualities, but is more friable and melts at 189 degrees centigrade, 388.4 degrees Fahrenheit. Oil of cascarilla is not used pure in perfumery, the bark being generally employed instead. Oil of cassia, Oleum cassiae, has a yellow color, gradually becoming dark reddish-brown, and an odor resembling that of oil of cinnamon, but the odor is not so fine nor as strong as that of the latter. The taste of the oil is of special importance. While that of true oil of cinnamon is burning, though sweet, oil of cassia has a sharper taste, and this taste is considered by some a good mark of recognition of the rather common adulteration of true oil of cinnamon, which is much more costly. Oil of cedar. This oil, obtained from the wood of the Juniperus virginiana, not from the true cedar, Cedrus libani, is clear like water, has a pleasant odor, and differs from most essential oils by congealing at a very low temperature, minus 22 degrees centigrade or minus 8 degrees Fahrenheit, and by its uncommon resinification in contact with air. Oil of citron. Oil of citron is usually merely a synonym for oil of lemon, but in perfumery it has been customary to designate the oil of lemon which was extracted by the écuelle process as oil of citron zeste or oil of citron, while oil of lemon meant the distilled oil. Since there is no difficulty at the present time in obtaining all the hand-pressed oil that may be required, and of the finest quality, there is no longer any necessity for making the before-mentioned distinction. Oil of lemon, Oleum limonis, Oleum citri, is one of the most important essential oils for the perfumer, as well as the manufacturer of liqueurs, confectioner, etc. The oil is pale yellow and of a very strong, refreshing odor, which it loses rapidly in contact with the air, when it acquires a disagreeable odor of turpentine and gradually resinifies. This change is particularly marked under the influence of light. Its specific gravity is 0.850 at 20 degrees centigrade, 68 degrees Fahrenheit. It is soluble in an equal volume of strong alcohol or glacial acetic acid. The hand-pressed oil has a much finer aroma than that obtained by distillation. Oil of citronella. This oil is hardly ever made in Europe, since it is imported in excellent quality and at low prices from India, and especially the island of Ceylon. Oil of lemongrass. This oil, which is imported in considerable quantities from India, chiefly Ceylon, is colorless and possesses a very pleasant odor of lemon, which at the same time recalls that of roses, and still more that of geranium, which is not rarely adulterated with it. Oil of coriander, Oleum coriandi, has a pale yellow color and a burning, sharp, aromatic taste. Like oil of cubebs, Oleum cubebe, oil of dill, Oleum anethi, and oil of fennel, Oleum feniculi, which latter also has a rather low congealing point, minus 8 degrees centigrade or plus 17 degrees Fahrenheit. This oil is used less in perfumery than for scenting soap and in the manufacture of liqueurs. But it should be noted that these oils, as well as those of bergamot, caraway, star anise, and some others, could well be employed for cheap perfumes and for scenting soap. Oil of dill also finds application alone in the preparation of some face washes, and the dried fennel herb in cheap sachets. Oil of lilac can be made at slight cost from the flowers, as the raw material is obtainable without much trouble. It forms a yellow, strong-scented oil. In perfumery, however, use is generally made only of the pomade made from the fresh flowers or the alcoholic extract prepared from it. or else the odor is imitated by means of terpineol, which is now on the market under the name of lilacin. Oil of geranium. It is necessary to distinguish clearly between oil of true geranium, distilled in southern France and Algiers, from species of pelargonium and Turkish oil of geranium, also known as palmarosa oil, oil of geranium grass, oil of rusa grass, etc., which is distilled in India from ginger grass. The first mentioned oil has a much finer aroma than the second. The two oils are frequently confounded, even in prominent works of reference. When oil of geranium or of rose geranium is directed to be used, the French or Algerian or Spanish oil should be employed. These cost more than twice as much as the so-called Turkish or palmarosa oil. Oil of heliotrope. This oil, which does not yet occur in commerce, we find merely the pomade and the alcoholic extract of the latter, has been made by the author experimentally. The most suitable method was found to be extraction with petroleum ether. As the plant Heliotropium peruvianum, the source of this delightful odor, is frequently cultivated in our gardens, the preparation of the oil by this method is to be recommended, being less expensive and more rapid than by the use of fat, while the product obtained with petroleum ether is as fine as that extracted by alcohol from the pomade. Oil of elder, Oleum sambuci. The remark made under the head of oil of lilac applies equally to this oil. For the benefit of those who wish to make this oil in its pure form, we may add that it is absolutely necessary to select only the freshest flowers, otherwise the odor will be very much impaired. Oil of jasmine, not to be confounded with the oil of syringa or German jasmine, Philadelphus coronarius, is colorless or yellowish and has a very strong, almost narcotic odor. It is one of the most valuable and at the same time most expensive aromatic substances employed in perfumery. Genuine oil of jasmine can be obtained only from southern France at very high prices. What is usually sold as oil of jasmine is a fixed oil impregnated with the aroma of jasmine. Oil of cherry laurel is not used as such in perfumery. At most, cherry laurel water may be employed. But as this has the odor of oil of bitter almond, and as the presence of some prussic acid, on account of which the officinal cherry laurel water is used, is of no value to the perfumer, and is in fact undesirable owing to its poisonous quality, we substitute in all cases a corresponding quantity of oil of bitter almond for cherry laurel water. Oil of culilabin, Oleum culilabana, is light brown, somewhat viscid. The odor recalls that of the oils of cinnamon, sassafras, and clove. It has been used for scenting soap. Oil of caraway, Oleum cari, is light yellow and has an aromatic odor and a burning taste. In perfumery, it is used only for very cheap odors and for scenting soap. It finds its chief application in the manufacture of liqueurs. Oil of lavender, Oleum lavandulae. This oil is of great importance to the perfumer and is imported in unsurpassed quality from England, Mitcham. It is light yellow, has a burning, sharp taste, and is exceedingly sensitive to light and air, under the action of which it loses its refreshing odor in a very brief time and acquires a common smell recalling that of turpentine. The buyer of this oil should take care to secure the true oil of lavender from Lavandula vera, for the oil of spike lavender is sold under the same name. This, prepared from Lavandula spica, has a similar odor to the genuine, but cannot be compared with it in delicacy. For this reason, too, the difference in the price between the two is considerable. True English oil of lavender costs 10 times as much as oil of spike lavender. The English brand of the true oil is of so excellent a quality that it brings 4 or 5 times as much as the best French oil, which is sold under the name of Huile de Lavandre des Alpes. Yet during the last decade or so, the French oil of lavender flowers has become so much improved in quality that it has become a serious rival to the Mitcham oil. Oil of wallflower, made from the flowers of the well-known garden plant, and oil of lily, likewise from the ornamental plant, are, strange to say, not manufactured in any place to our knowledge. Experiments made by us in this direction prove that the odors of these plants can be obtained either by absorption or more readily by extraction. The perfumes thus far occurring under these names are always combinations of different scents, which, though pleasant, have but little in common with the plants whose names they bear. In this connection, we may say that the perfumes sold under the names of various flowers often have no relation to them, but are mixtures of various odors. While it cannot be denied that perfumes may be made in this manner, which resemble those of the respective plants, it is unquestionably an imperfection in the art of perfumery that these odors are not really made from the flowers mentioned. To give another characteristic instance, we may add that the delightful odor of the well-known lily of the valley, Convallaria majalis, a plant which grows wild abundantly in many of our forests, has not yet been produced, and that even imitations of this odor, which in delicacy and fragrance stands next to those of the rose and violet, are seldom met with in commerce. Oil of lemon, Oleum limonis, obtained from the fruits of the lemon tree, is one of the most important products, both statistically and economically, of the citrus family. In German works there is often a confusion between oil of citron and oil of lemon, it being supposed by the authors that citronenol is derived from the citron, Citrus medica, and the lemonenol from the lemon, Citrus lemonum. There is indeed some oil made occasionally from the citron, but it does not figure in price lists. The oil of the lemon, on the other hand, is very commonly called citronenol, and the fruit itself citron. Hence, when citronenol is quoted in a formula, it may be assumed at once that oil of lemon is intended. It is very liable to resinify when it loses its fragrance. Oil of sweet bay, laurel, Oleum lauri, is green and usually mixed with the fixed oil of the same plant. It finds more frequent application in the manufacture of liqueurs than in perfumery, but as it has a pleasant odor, it might well be used for cheap perfumes. But in that event it must be freed from the fixed oil by distillation. Oil of magnolia, likewise, has not yet been prepared as such. The remarks made above under the heads of oils of lily and wallflower apply also to this odor. The so-called magnolia perfumes are mixtures of different odors. Oil of marjoram, Oleum marjorani. Oil of marjoram, which is obtained by distillation from the dried herb, has a strong aromatic odor. It is mentioned as having often been used in perfumery for scenting soap instead of oil of thyme, whose odor, moreover, is very similar to that of marjoram. But this is a mistake, due to the fact that ordinary oil of thyme has long been sold under the name of oil of origanum. True oil of marjoram costs about $12 a pound, while oil of thyme, so-called oil of origanum, is worth only about 80 cents. It is rarely employed for volatile perfumes. Oil of melissa. The oil of Melissa officinalis, owing to the very small yield, is quite expensive. It is used only for the preparation of some perfumes which owe their peculiar qualities to this strong odor. This oil must not be confounded with the spurious oil of Melissa, also called oil of citron melissa, which is identical with oil of lemongrass. Oils of mint. Although all the mints possess an agreeable odor, only 3 varieties find extensive application. There are the oils from Mentha peperita, peppermint, Mentha viridis, spearmint, and Mentha crispa, crisp mint. The oils of English manufacture are highly esteemed, but the United States also produces them of excellent quality. At one time the cultivation of mints, particularly peppermint, was greatly extended, with the exception of deriving satisfactory profit from the enterprise. It has, however, been conclusively shown that the market cannot absorb more than a certain quantity of these products, and that any overproduction brings loss and disappointment to the investor. Beside the three kinds of mints above mentioned, there is another species, Mentha arvensis, a native of Japan, which is extensively cultivated there, and is the chief source of the menthol of commerce, so well known as an efficient remedy for neuralgia, migraine, etc., in form of menthol cones. The three varieties of the mint oils previously mentioned are distinguished, aside from their pleasant odor, by the property of leaving a very refreshing and cooling taste in the mouth, and for this reason they form the most important constituent of all fine mouthwashes. True oil of peppermint, Oleum menthae piperita, when pure, is colorless, very mobile, of a burning sharp taste which is followed by a peculiar coolness. The commercial product is usually pale green. Oil of crisp mint, Oleum menthae crispae, which in Europe is often sold to novices as oil of peppermint, has always a more or less yellow color and resembles the oil of peppermint in its properties, but it is less fine and cheaper. The same is true of the oil of spearmint, but this has a very characteristic odor and taste, distinctly different from peppermint. As above stated, the oils of mint are extremely useful for mouthwashes, also for scenting soap, in liqueurs and pastilles, but rarely in handkerchief perfumes. Oils of mace and nutmeg, Oleum Michaelides and Oleum myristicae. These oils are prepared either from the seed coat, Oleum Michaelides, or the nutmeg itself, Oleum myristicae. Oil of mace generally has a yellowish-red color in tint, varying from dark to light and even colorless. Its taste is agreeable and mild, and the odor exceedingly strong. Like oil of nutmeg, it is extensively used in the manufacture of liqueurs and for scenting soap. The oil prepared by distillation from the nutmeg is, when fresh, almost colorless or at most faintly yellow, of a burning, sharp taste and an aromatic odor. Like oil of mace, it is used in the manufacture of liqueurs and soaps and also in many perfumes. In India, a third valuable product is obtained from the nutmeg by expression of the ripe fruits and is called nutmeg butter. This is bright yellow and consists of a true fat and an essential oil. Its odor is very pleasant, and a very superior soap can be made by saponification of this valuable product with soda lye. Oil of myrtle. This oil is of a greenish color and very mobile, but it is not a commercial product. The manufacturer must prepare the oil himself from the leaves, though the yield is small. The articles sold as so-called essence of myrtle are always mixtures of different odors. Southern France, however, exports at high prices a myrtle water, eau des ongles, which is really made by distillation of the leaves with water. Oil of narcissus. As to the odor to which this flower owes its fragrance, we may repeat what we have said just now with reference to the oil of myrtle. We have never succeeded in obtaining this oil in commerce. The so-called essence of narcissus, though a very pleasant mixture, contains no trace of the true oil. As to oil of pink, the same remark applies. The compositions sold under the name of essence d'oilette, however, have a very striking odor of pink. Oil of clove, Oleum caryophyllae. This oil, when fresh, is colorless, but soon becomes yellowish or brown. It is heavier than water, in which it sinks, and is characterized by an exceedingly strong burning taste and a spicy odor. It remains at least partly fluid at a very low temperature, namely -20° centigrade, -4° Fahrenheit. Oil of orange flowers, Oleum naphei, Oleum neroli. Commercially known also under the French name huile de fleurs d'orange, huile neroli, huile neroli pétale, is obtained from the flowers of the orange tree in southern France, where the orange is specially planted for this purpose. The odor of the oil varies with the mode of its preparation. That obtained by distillation with water has a different odor from that made by maceration with fat and extraction with oil. The latter variety of oil as such, however, is not found in commerce, the alcoholic extract entering at once into the composition of the perfumes. The French manufacturers of this oil, which is of great importance in perfumery, distinguish several varieties. The most valuable is the oil from the flowers of Citrus vulgaris, or Citrus bigaradiea, the true bitter orange, or Seville orange tree. This is the so-called neroli bigarade. That called neroli petale is obtained from the same flowers, carefully deprived of their floral envelopes, so that only the petals are subjected to distillation. Much cheaper than these two is the oil of petite grain, which is distilled from the leaves, and sometimes also unripe fruits of various trees of the citrus order. All these oils are among the most delicate. When fresh, they are colorless and have a peculiar bitter taste. Exposed to light and air, they assume a reddish tint and undergo rapid resinification. They should, therefore, be preserved in particularly well-closed vessels in a dark, cool place. Not to be confounded with these oils is the oil of orange, of which there are two kinds, one from the bitter orange, known as oil of orange, bigarade, and the other from the sweet orange, also known as oil of Portugal. Both are extracted from the peel of the fruit by mechanical means. Both oils of orange peel are golden yellow and have a pleasant, refreshing odor, recalling that of the fruit. They find application for scenting soap, in toilet waters, and in some true perfumes. When oil of orange or oil of orange peel is mentioned in any formula without further specification, the oil of bitter orange peel should be used. Oil of patchouli. This oil, which might be manufactured with advantage in India, the home of the plant, strange to say, not imported from that country, but is distilled in Europe from the dried herb. Fresh oil of patchouli is brown in color, very viscid, almost like balsam, and surpasses all other essential oils in the intensity of its odor. Owing to the strong odor, pure oil of patchouli must really be called ill-smelling. Only when highly diluted does the odor become pleasant, and then forms a useful ingredient of many perfumes as the fundamental odor in the harmony. Oil of syringa. Oil of false jasmine from the flowers of Philadelphus coronarius is not made as such. In southern France, however, the flowers are frequently used for the preparation of a cheap pomade known commercially as orange flower pomade. A personal experiment made with the view to obtain the pure odor by extraction of the flowers with petroleum ether has shown that this plant is suitable for making very fine preparations, both handkerchief perfumes and pomades. Oil of allspice, of a burning, sharp taste and odor, is colorless, but is hardly ever used for the purposes of the perfumer, at most for soaps, but all the more frequently in the manufacture of liqueurs, and particularly also in that of artificial bay rum. Oil of sweet pea has not been made thus far, though there is no doubt that this perfume, too, can be prepared pure from the alcoholic extract of the pomade. The properties of the oil should resemble those of the finest neroli petale. Oil of rue, Oleum rutae. This oil, obtained by distillation of the herb, is colorless or pale yellow, of a very strong penetrating odor. It is used in some washes, but more particularly as an ingredient in the manufacture of artificial cognac, for which purpose the plant is specially cultivated in France. Oil of reseda, mignonette. The delightful odor of this plant, which formerly could only be fixed by maceration in fat, may be readily prepared by extraction with petroleum ether. Yet special precautions should be taken that nothing but portions of the flowers, carefully picked off, and no green leaves are extracted. The oil thus obtained has a yellow color and a disagreeable odor, which changes into the well-known pleasant smell of the flower when highly diluted with alcohol. Oil of rose, Oleum rosea, also known as attar or otto of rose. The various species of roses give different odors. The commercial Turkish, Persian, and Indian oils of rose, which latter is never exported, which, by the way, are very generally adulterated even at their point of production, are derived mainly from Rosa damascena, and when highly diluted yield the pleasant odor of our ordinary garden roses. The rose oils having the odor of the moss rose, tea rose, or dog rose, are made almost exclusively in France, and in commerce do not appear pure, but generally in the form of pomades or alcoholic solutions known as essence de rose. True rose oil is yellowish or yellow, or else greenish, and varying from liquid almost to the consistence of butter. Between these extremes there are all possible gradations. A comparatively very high congealing point is a characteristic of oil of rose. It becomes almost solid at 14 to 20 degrees centigrade, 57 to 68 degrees Fahrenheit. The portion separated during solidification is colorless, markedly crystalline, and, strange to say, almost odorless. Pure oil of rose smells disagreeably narcotic. Only the very dilute solution shows the incomparable fragrance. Much superior to the oils of rose which are prepared from the rose leaves, either fresh or salted, are those obtained by maceration or extraction with petroleum ether. Those perfumes sold under the name of various species of rose, such as moss rose, etc., are combinations of rose oil with other aromatics. Oil of rhodium. This bright yellow light oil is obtained by distillation of the wood of Convolvulus scoparius. At times this oil is scarce in commerce. It has a faint but decided odor of rose. Oil of rosemary, Oleum rosmarina. This oil is obtained by distillation from the herb of the rosemary plant as a thin, pale green fluid with an aromatic odor and spicy taste. It is used as an ingredient in some old renowned handkerchief perfumes, for instance, cologne water, also for flavoring soaps and liqueurs. Oil of sage, Oleum salviae. From the flowers of Salvia officinalis, is yellowish, with an odor somewhat similar to that of oil of peppermint, but far less intense. Like the latter, it imparts a pleasant coolness to the mouth, and hence is used in some mouthwashes. Oil of santal, Oleum santali. The oil of santal wood, also called sandalwood oil, has a thick, honey-like consistence and an agreeable rose-like odor. Formerly it was sometimes used for the adulteration of oil of rose, but can also very well be used alone for several perfumes and fumigating preparations. Oil of sassafras, Oleum sassafras, is yellow, spicy, with a burning odor and taste. In the cold it crystallizes only in part. The odor of this oil recalls that of fennel. The purest form of it, or rather substitute for it, is saffrol, its main constituent, which is, however, now extracted more economically from crude oil of camphor, in which it likewise forms an ingredient. Oil of meadowsweet, Oleum spiræ. Several species of spiræ, and especially Spiræa ulmaria, furnish very pleasant odors. This oil consists mainly of salicylic aldehyde. Despite its pleasant odor and the facility of its production, this substance has thus far found little application in perfumery. The natural oil of meadowsweet, owing to its extremely high price, can hardly ever be used. Oil of star anise, Oleum anisis salati, Oleum alici. Resembles in its properties the oil of anise, even in its odor, but all connoisseurs agree that the odor of the oil of star anise far surpasses that of the oil of anise, hence the former is used especially for fine perfumes. This preference, however, does not extend to all preparations. For certain liqueurs, such as anisette, the oil obtained from common anise, Saxon anise, is usually preferred. Many also regard the odor of star anise as inferior to that of fine European anise. Oils of thyme, Oleum thymi. The essential oils of thyme, chiefly Thymus vulgaris, and some related plants are very frequently used for scenting cheap soaps. The oils of these plants are light yellow and so similar in odor that it is not possible to distinguish them except by direct comparison. Oil of vanilla, or more correctly, vanilla camphor, the true odorous constituent of vanilla, also called vanillin, is a crystalline substance with a delightful odor, melting at 76 degrees centigrade, 169 degrees Fahrenheit. This is now extensively made artificially from the cambium sap of pines, the coniferin being converted by chemical process into vanillin. 1 ounce of good vanillin is equivalent to about 40 ounces of the best Mexican vanilla beans. Oil of violet has thus far been produced in but very small quantities from the alcoholic extract of the true violet pomade. It has a greenish color and, when pure, a narcotic odor not to be recognized as that of the flower. The pleasant odor of violets manifests itself only in extreme dilution. Oil of verbena is yellow with a very pleasant odor of lemons. Its price being quite high, it is usually adulterated with oil of lemongrass, or else the latter is sold under the name of oil of verbena. In fact, the odors of the two oils are so similar that they are easily confounded. Oil of vetiver, Oleum ivarenchuse, from Andropogon muricatus, is viscid, reddish-brown, with a very strong and lasting odor. Oil of wintergreen, Oleum gaultherae. This product is obtained by distillation from the leaves and twigs of Gaultheria procumbens, or else by distilling the bark or leaves of Betula lenta with water, in which case the oil is generated by the action of the water, as it does not pre-exist in the birch, and moreover, in this case the oil consists of nothing but methyl salicylate. It differs, like oil of meadowsweet, very markedly from the other aromatic substances, and mainly consists of the so-called compound ether. It is a salicylate of methyl, boils at 220 degrees centigrade, 428 degrees Fahrenheit, is much heavier than water, specific gravity 1.173 to 1.184, and dissolves readily in alcohol and other solvents. It is used chiefly for scenting soap. The perfumes sold as wintergreen are usually mixtures of different substances which contain no oil of wintergreen. Oil of ylang-ylang, Oleum unane odoratissime, is imported from Manila. It is colorless or yellowish, and has a most delightful characteristic odor, which is rather fugitive if not made resistant by other substance. It forms an important constituent of several of the most favorite and expensive essences. Oil of hyssop, Oleum hyssopi, is colorless, but rapidly becomes yellow in the air. It is used in some very cheap perfumes and in the manufacture of liqueurs. Oils of cinnamon, Oleum cinnamomum. Commercially, we find chiefly 3 varieties of essential oils, which are designated as oil of Ceylon cinnamon, oil of Chinese cinnamon, or oil of cassia, and oil of cinnamon leaves. Oil of Ceylon cinnamon, sometimes called true oil of cinnamon, made from the bark of the twigs of the cinnamon laurel, and formerly imported mainly from Ceylon, but now distilled in large amounts in Germany from imported cinnamon chips, is rather viscid, golden yellow to reddish-brown in color, of a burning though sweet taste. In the air it gradually absorbs oxygen, when it becomes dark red, thicker, and of weaker flavor. Oil of Ceylon cinnamon, which should always be used in perfumes or liqueurs when simply oil of cinnamon is directed, has a specific gravity of 1.030 to 1.035 at 15 degrees centigrade, 59 degrees Fahrenheit, and boils at about 240 degrees centigrade, 464 degrees Fahrenheit. Its chief constituent, upon which its aroma depends, is cinnamal aldehyde. Oil of Chinese cinnamon, or oil of cassia, has for a very long time, up to within a few years, always reached the market in a more or less adulterated state, a regular practice of the Chinese exporters being to dissolve ordinary resin in it, claiming afterward that the resin was caused by the oxidation of the oil through age, and often also to add petroleum to it. These frauds have been well shown up by Schimmel and Company of Leipzig, and in consequence thereof the quality of oil of cassia exported from China has been greatly improved. Oil of cassia, when pure, has a specific gravity of 1.060 to 1.065 and should contain not less than 75% of cinnamyl aldehyde. Oil of cinnamon leaves is an inferior product, often used for adulterating oil of Ceylon cinnamon. It does not deserve notice by the perfumer. As an appendix, we may add in this connection a description of oil of turpentine, Oleum terebinthinae, because it must be called an important substance to know for the perfumer, inasmuch as it is very frequently used for the adulteration of different essential oils. Oil of turpentine, which is obtained from incisions into the bark of different fir and pine trees, the exuding resin being distilled with water, comes into commerce from various sources. Different sorts are distinguished, but to the perfumer only the rectified oil of turpentine, Oleum terebinthinae rectificatum, is important. Oil of turpentine has a yellowish color and a decidedly disagreeable, resinous, and burnt taste. By repeated distillation, especially over quicklime or chloride of lime, bleaching powder, it is finally obtained as a colorless, very refractive liquid with a density of 0.855 to 0.870 and a boiling point at 160 degrees centigrade, 320 degrees Fahrenheit. Its odor is peculiar, but not easily distinguished from that of old essential oils, such as oils of caraway, anise, etc. One peculiarity of oil of turpentine is that its odor is easily masked by that of other essential oils, so that, for instance, a comparatively large quantity of oil of turpentine needs the addition of but little oil of anise to impart the entire mixture a rather pronounced odor of anise. This peculiarity has led to the frequent employment of rectified oil of turpentine for the adulteration of other essential oils. End of section 10, the special characteristics of aromatic substances.